Assembly of water level monitoring. Components required: one NodeMCU, ultrasonic sensor, voltage regulator, 9-volt battery, battery snapper, breadboard, and a USB cable. First of all, we will place the ultrasonic sensor. The ultrasonic sensor has 4 pins: VCC, trigger, echo, and ground. We will connect the trigger pin to the D1 pin of the NodeMCU and the echo pin to the D2 pin of the NodeMCU. Take some male to female jumper wires. Connect it to the trigger pin and connect the wire to the D1 pin of the NodeMCU. Similarly, using jumper wire, connect the echo pin to the D2 pin of the NodeMCU. Now place the voltage regulator on the breadboard. Take the battery snapper. Connect its positive to the V-in pin of the voltage regulator and the negative to the ground pin of the voltage regulator. Then take the VCC pin connect the VCC pin of the ultrasonic sensor to the VU pin of the NodeMCU. this one, VU pin. Then connect the ground to the ground pin of the NodeMCU. Then take 2 more wires. Connect the Vout pin of the voltage regulator to the V-in pin of the NodeMCU. And the ground pin to the ground pin of the NodeMCU. So our assembly is done, and now we can power our NodeMCU using the battery. But if you don't want to do that, you can remove the V-in pin and the ground pin of the voltage regulator, and then use the USB cable. Connect it to the laptop or desktop, whatever you are using, and connect the other terminal to the NodeMCU to power it. Thank you.
So after doing the hardware connection for the water level monitoring, now we will do the Blynk configuration. So we will go to the Blynk website, and then in the dashboard we will select a new template. Here we will give the template name as water level. Select the hardware as ESP8266, connection type as Wi-Fi, and then click on Done. Then go to the data stream, click on New Data Stream, select the virtual pin, give the name as suppose water level, and then select the maximum value as 500, and then click on Create. So once it is created, now we will go to the web dashboard, and from the widget box we will select the gauge and drag it to the dashboard. Click on the setting option, select the data stream as water level, and then click on Save. After that, we'll go to the events and notification, click on Create Event, Custom, give the event name as water indicator, give the code as water level increased or anything you want, and then go to give the type as warning, go to the notification, enable the notification, click on push notification to and select device owner, and then enable notification management, deliver push button as alerts, enable all those. Go to the settings, select the event will be sent to as 1 minute, as 1 minute is okay. Then enable if you want the notification in the device page as well as home screen, and then click on Create. Your event is created. Now click on Save. We will require this code during the coding, So our template is created, water level. Now we will add the device. So click on devices, click on new device, click on from template, choose template as water level, click on create. So you got the template ID, template name and the auth token. So copy this and then click on device. You can see the new device is created. So this is all about the Blynk website configuration. So this is the coding for the water level indicator. So here first we have added the Blynk template ID and the Blynk template name we got from the Blynk website. And here we have defined the trigger pin as the D1 pin as the trigger pin and the D2 pin as the echo pin. Then we have included the ESP8266 Wi-Fi and the Blynk libraries. The ESP8266 will connect the NodeMCU to the Wi-Fi and the Blynk library will connect the NodeMCU to the Blynk server. Here we have given the token that we have taken from the Blynk website. This is our Wi-Fi ID and Wi-Fi password. And in the voice setup, we have started the serial monitor with a baud rate of 9600 and Blynk.begin will connect our NodeMCU to the Wi-Fi and the Blynk server. Then we have declared the trigger pin as output and the echo pin as input. Now inside the void loop, we have created two variables, duration and distance. Now to making the trigger pin low for 2 microseconds, then high for 10 microseconds, will generate the waves of the sensor. So here we have used the digital write function to make the trigger pin low and have given delay 2 microseconds. And then again we have made the trigger pin high for 10 microseconds and then we have made the trigger pin low. And then we have created a variable duration that will store the time duration for the wave to reach the echo pin. So here we have used a pulsing function and we have made the echo pin high. So this will read the duration for the wave to reach the echo pin and will store the time duration in the duration variable, and we convert this duration into distance by multiplying it with 0.034 and dividing the value by 2. This will convert the value into centimeters and store this in the distance variable. Then we will check the distance. If the distance is less than 100, that means the water level is very high, and using the blynk.log event, we will trigger the Blynk event and send the notification in the Blynk app, and else it will print the distance in the serial monitor, and the blynk.virtualWrite v0 will send the distance to the Blynk virtual pin v0. Then we will able to see the distance on the app, and then blynk.run is used to keep the Blynk connection alive. So this, after the code is done, we will click on tools. Under the board, in the board manager, under the ESP8266, we will select either NodeMCU 0.9 or NodeMCU 1.0, and then from the port select the required COM port and then click on upload. The code will be uploaded to the NodeMCU. Blynk mobile configuration for water level. First of all, open the Blynk app. As you can see, the template water level monitoring is showing here. Click on the template, click on setting, click on the plus symbol and then select gauge. Now click on the gauge, select the data stream, the water level which we have created with virtual pin v5. Go back. You can see the water level gauge is displayed on the template. Thank you. Output of water level monitoring. First we will open the Blynk IoT app. Open the template. You can see the gauge is showing the level of the water. So if I put the ultrasonic sensor in front of an empty container, or when there is nothing in front of the ultrasonic sensor, its value increases. But when we put it in front of an full container, as you can see, the value decreases and a notification is sent showing your water is full.
Similarly, if I want to see on our dashboard, so first we have to open our device, the water level monitoring. As you can see, the gauge is displaying the level, and as soon as I put the sensor in front of the water, the value decreases. Thank you.